Hi there. Alright, so since I'm here up at night in my pajamas doing this with you with my dear husband recording, I might as well help you with a homework problem that Andrea emailed me asking for help. So it's the suicidal bird problem, right? You have a 600 gram falcon, excuse me, I got too funny. It's problem 8.28 on page 262. It's a homework problem from chapter 8. Suicidal bird. A falcon sees a raven approaching its nest and decides to not let the raven come and eat its eggs. So the 600 grams falcon speeds up, travels really fast in the direction of the raven at 20 meters per second. And the raven is moving in a perpendicular direction. I chose here the raven to be going up and the falcon to be going right, but it doesn't matter. The fact is that they are moving in perpendicular directions. The falcon this way, the raven I chose to be going up at 9 meters per second. The question is, what happens to the raven after the collision? And we are told what happens to the falcon. Not only it dies, but it goes back, it bounces back at 5 meters per second. What happens to the raven? So that's pretty much the question. So this is a problem that has to do with conservation of linear momentum. We have that the linear momentum before the collision should be the same linear momentum after the collision. So what we'll do is we're going to analyze the linear momentum before and after in the two components of the linear momentum that are perpendicular, x and y, and they should be the same. So let's see. Before the collision right here, we have an initial, a px initial. So the only thing traveling in the x direction is the falcon, right? The falcon, so it will be the mass of the falcon times the velocity of the falcon, which is mass of the falcon 600. Remember that it should be 0.6 kilograms times 20 meters per second. And if you do the math, you will find that it's plus 12 kilograms meters per second. The plus is simply saying that I chose my positive axis to be to the right. And the P, the initial linear momentum in the y direction, is due just to the motion of the raven, and therefore it's mass of the raven times the velocity of the raven. Again, because the falcon is not moving up or down, and if you do that math, you'll find out that that's plus 13.5 kilograms meters per second. All right. What do we know about after? So this is the beginning. We know that the linear momentum will be conserved. So what do we know about after? All right. So the linear momentum in the x direction after the final, we know that there is a component that will be due to the falcon, and that component is actually opposing the initial linear momentum. Therefore, the raven is going to have some linear momentum to the right, and it's going to have enough so that this plus this is equals the initial momentum that we have. So in the x direction, we have the mass of the falcon again. I'm going to put numbers here now. The mass of the falcon is 0.6 times the velocity of the falcon is minus 5 because it's now going in that direction, times minus 5 meters per second. And then there's going to be one component which is going to be the mass of the raven, 1.5 kilograms, times whatever is the velocity, the final velocity, the final x final of the raven. Okay. But we know that Pfx equals Pxi. So we know that all of this, 0.6 times minus 5 is 0.6 times minus 5 is minus 3. Can't think. All right, so P So P of x equals Pxi, which is plus 12 kilograms meters per second, equals 0.6 times 0.5 is minus 3, again kilograms meters per second, plus 1.5 times the velocity, the final velocity in the x of the Raven. And if you do this, if you solve here, you'll find that the Vx final of the Raven is 10 meters per second. Alright? 10 meters per second. Now, to determine the Vy final, you actually don't need to do any computation at all, because there's no change in the y direction, right? And the linear momentum needs to be conserved. So if nothing, if the Falcon hasn't changed and it's not moving up or down at all, then the Raven cannot have changed on how fast it's going up or down either. So the initial velocity is the same as the final, because this, the Pyi, the mass of the Raven, times the velocity of the Raven, has to be the same at the end. The velocity of the Raven has to still be 9 meters per second going up. I hope that's clear. So then what we want to know is what is the final magnitude and direction of that velocity. So I'm going to draw here that the Raven is going at 10 meters per second to the right and continues to go at 9 meters per second up. Alright? So the total velocity of the Raven is here the hypotenuse of this triangle. Oh my goodness, that's bad. That's what you get when you don't have a ruler. There you go. And so if you compute the hypotenuse using the Pythagorean theorem, you will find that this velocity here is 13.45 meters per second. And you do that just by doing this square plus this square, take the square root. This is the magnitude, and we want to find the direction. But the angle we want to find is the angle with the initial direction. The initial direction was this one, alright? Look there, that's the initial direction. So this is the angle we want to find, theta, right there. So this angle is, there are many ways you can do it. You can do tangent of theta equals 9 over 10, or sine of theta equals 10 over 13.45, or cosine of theta equals 9 over 13.45. Then you do the inverse of that in your calculator, and you get that your angle is 48 degrees here with the y direction. Alright? And that's the tail of the suicidal falcon. Okay, see you later.